Alright, in this video we're going to be looking at AC circuits. An alternating current, or AC, is a type of current that changes its magnitude and direction periodically. So they change their magnitude and direction periodically. AC are produced by alternating voltages. So you see they move in one half circle and oscillate in the other half circle. So AC currents are represented by this. So AC are produced by alternating voltages. Now, unlike DC current, AC currents are represented in terms of time. For example, the current through an AC circuit is given as IT. It's going to be equal to I naught sine omega t, or I naught sine 2 pi ft. Okay, this is because omega, that's the angular speed, is equal to 2 pi f. Again, we can also say this for the voltage. You can also say this for the voltage. So for the voltage, Vt, that is the instantaneous velocity, is equal to V naught sine omega t, or V naught sine 2 pi ft. Again, omega is equal to 2 pi f. Omega is the angular speed of rotation of the, or of oscillation of the wave. They are represented as sinusoidal or sine wave. So we call them sinusoidal or sine wave. Okay. Now let us explain the terms V naught and I naught. V naught and I naught. V naught or I naught represents the maximum or peak voltage. Okay, the maximum or peak voltage. Why I naught? Okay, that's for V naught. I naught is the peak or maximum current. Okay, basically they mean the same thing. Okay, just that one is for current and the other is for voltage. So when dealing with AC circuits, so I'll replicate the circuit again, the sinusoidal wave. So this is a sinusoidal wave. Okay, so so this could be any particle with x sub t in this direction, and this will be the time in seconds. So s of t could be v of t or I of t. So it could be current. So what that means is that, what I'm trying to say is that the peak value is the maximum point here. So this is the peak value, S naught. So S naught, remember, S naught represents V naught or I naught. So that's the peak value. So you can also have it done this way. So this is also the peak value, but on the negative side. Okay, so the peak value, or the peak value of voltage, will be the maximum current or voltage from this main position here. Okay, then another term we have to associate ourselves with the peak to peak value. So the peak to peak value is 2x naught. So what that means is that if I have a sinusoidal wave of, let's say, voltage let's say this is present v of t, and this is t, time in seconds. Then we'll have a sinusoidal wave like this. Then the peak-to-peak value is going to be 2v0. Okay, so for instance, if the peak value here is 5 volts, that's v0 is equal to 5 volts. Then the peak-to-peak value will be equal to 5 plus 5, which is 10 volts. So the peak-to-peak value represents this value down this way. So that's peak-to-peak what? From the peak here to this point here. So that also applies for the current. So for current I naught, let's say the peak current is 2 amp or 2 milliamps. Then the peak-to-peak current or value of current is going to be equal to 2 times 2 milliamp. So that's 4 milliamp. Okay. Next, the next thing we have to look at is going to be, we're going to look at some terminologies. So like we said from the beginning, I said that the current or the voltage in any given time, the instantaneous voltage is equal to V0 sine omega t, and IT is equal to I0 sine omega t. Now, we already know what V0 and I0 are. These are the peak values of current and voltage. So we want to look at other parameters now. So the parameters that we are going to look at now are the root mean squared values. That's RMS. So the root mean values of an AC circuit is the values of current and voltage that will have the same effect as the DC current and voltage. Okay, so in other words, they will produce the same effect, or we can say that the root mean values of current and voltage of an AC circuit are the effective values of the AC current and what? Voltage. So they are the effective value. They give the effects that a DC circuit will produce. The effects are the heating effects. So that means you can actually use the root mean value to calculate the power of AC circuits.